So we're given different rates to use in each year. Let's look at a time chart. So here we see the time periods along the bottom. And in the first time period, from time period 0 to time period 1, the rate given to use as the discount rate is 5%. From year 1 to 2, it's 6%. From year 2 to year 3, it's 7%. From 3 to 4, it's 6%. And from 4 to 5, it's 5%. So these are, you may have heard them called forward rates because they're the rates that represent the actual discount rate, the true discount rate, in that time period between those two periods. So it's changing. The rate that we're going to use to discount the cash flows is not constant throughout this 5-year period. So the first cash flow we get is the $100 in year 1. Then we get the $100 in year 2, in year 3, in year 4, and finally we get the $100 plus the par value in year 5. So we get a total of $1,100 in year 5. So since there's a different interest rate for each year, we can't use the time value of money functions on our calculator. We can't just put this in as a $100 annuity for 5 years and a $1,000 future value and put in the interest rate and solve for present value because the interest rate changes. The easiest way to do this is to start from the last cash flow, discount it back one period, add it to the next cash flow, and continue all the way back to period 0. So that's exactly what we're going to do. So first, let's start with our last cash flow, the $1,100, and discount it back one period. And we're going to use the 5% because as we can see from this time chart, the interest rate being used as the discount rate between period 4 and 5 is 5%. So we discount that $1,100 back one period at 5%. And we get the value of that $1,100 in year 4 to be $1,047.619. So now we have a cash flow of $100 in year 4 plus the value of this $1,100 in year 4. What we're going to do is we're going to add that $1,047 to the $100 coupon in year 4 to get the total value of all the cash flows in year 4 of those 2 years. And then we're going to add that together. We'll have this new sum, and we'll discount that sum back at the 6% because as we can see from this time chart, the interest rate being used as the discount rate between years 3 and 4 is 6%. So that's exactly what we do. We take the 1047 plus the 100, divide the sum by 1.06. Now we have all those cash flows in year 3, and that's the 1082.659. Now we add that to the $100 coupon in period 3, and we can discount it back at the 7% because we can see between years 2 and years 3 is the 7% rate. So basically what we're doing is we're just discounting it back one period at a time so we can use the proper rate at each time. And as we go along, we're picking up the cash flows that we're earning in each period. So we add the 1082 to the $100, discount it back at the 7%. We get a value in year 2 to be $1,105.289. We add it to the $100 cash flow in period 2, discount that back at 6% because 6% is the rate used as a discount rate between periods 1 and 2. And we add those together, discount them back. We get $1,137.065 in year 1. We add that to the first cash flow of $100, and we find the present value of all of them since we've taken each of them and divided them, discounted them back at the proper interest rate being charged between each year. So we add that to the $100 and discount it back at the original 5%, the 5% that's being used as a discount rate between year 0 and year 1. So we do that and we find the present value of all of these cash flows at all of these different rates is $1,178.16. So that's the present value of all the future cash flows. That's the price of the bond. Now that we have the price, we can find the yield to maturity. So there are 5 years until the bond matures, so we enter in 5 for N. The current price we just found is $1,178.16. We enter that in as a negative value to represent a cash outflow. We're purchasing this bond. The coupon payments are $100. The par value is $1,000. And now we just solve for I. We find the yield to maturity to be 5.79%.